Okay, so because the time is so tight for this speech, so I might just focus on the OpenCompute or AI compute for Agentic AI, skip the open evaluation since just 15 minutes I want to talk about the one point more clear. So actually, I think I don't need to spend more time on how the impact or the compute has been changed from the ChatGPT to OpenClaw. Actually, for ChatGPT, it's really if we have a very excellent large model to run. But for the OpenClaw or Agentic AI, since it need a multi-rounder to execute the models and also the overall system. So actually, it's not only the single model's performance, but it's also the overall computation system if it has capabilities to support a more efficient inference and finish your overall task. So that's why we think the next bottleneck is not only the model's capability, but it's the infrastructure. So here you can see from this page, the left-hand side is just the past 3 or 4 months in this year. Different large model team, they has already released quite a lot of the outstanding models as the open source model or open weight model. So because of this, a lot of very good, excellent models has been open source. So it gives us the chance to deploy the model for our different purpose, for the purpose of security, privacy, better control, or better resilience. And also, sometimes we do need to post-training for the model for different innovation purposes as well. So when we do this deployment, we do need to have the more chip to support this deployment or more choice. So that's how we can lower the cost, of course, right? You can think about it today in global, how many different vendors still that they contributing to innovate the compute architecture, because today we still think the AI chip is not efficient enough. So still a lot of innovation. So that's why we do want these kinds of a new model when they release, it can be run on different chipset, okay? So I just want to use the DeepSeek version 4 as the example because it was released around 10 days ago, okay? So actually we do see that the DeepSeek is a very stress test for OpenCompute, okay? Because let's see, the DeepSeek version 4, why it is suitable for Agentic AI because it supports 1 million tokens for the context length. And it also supports a very strong tool calling and also the inference or the thinking. But on the other hand, DeepSeek, this model also heavily optimized for the system efficiency. It heavily optimized because it brings a hybrid attention, different attention for different layers, and also it used the heterogeneous KV cache mechanism. And also it used the FP4 and FP8, this very low precision. And also it introduced the new kernel and also the runtime optimization. So when we want to enable this new model on different architecture, what is the challenge? We need to consider currently a lot of the mainstream chipset has been deployed. Still, they cannot support the FP4 or FP8. This low precision. And also, DeepSeek version 4, when they release that, it will require the single device as larger, the memory larger than 80 gigabyte. And a lot of deployed device today has no such big memory space. And also, together with the open source model, the kernels, operator kernels, remain coupled with special hardware backend, okay? So that's why we think open compute is so important. That means that we need to find a way to allow this hardware-specific feature can run on the different architecture and decouple this limitation or this requirement. So when we want to migrate the DeepSeek version 4 around 2 weeks ago, when we start to migrate it, we need to consider how to solve these kind of things. The first is we need to replace those hardware-bound components with the unified software, unified cross-chip software. And also, this time, as the new model, they also introduced 5 new kernels. So we need to very quickly to implement those missing operators for DeepSeek. And also, we need to convert those unsupported precision format to other the mainstream device available for us. And also, we need to redesign the memory constraint mechanism for the parallelization, and also the optimize a lot of communication and tune the performance. But the most important thing is we also need to validate all the correctness and also to ensure that the benchmark accuracy. That means that we replace the underlying stack to other, but still we need to keep the precision for DeepSeek version 4 on different architecture. So how we do that? Actually, this is what we have done in the past 3 years. And this is called the FlagOS. It is the open source stack to support the system software on different chipsets. It today already supports more than 30 chipsets in the world, including the NVIDIA, Huawei, ARM, and some RISC-V, and all and more. Okay, and you can see that actually for those challenges or technical issues we need to solve, we by using this stack, one by one, we solve it. So let me go through this. But one more thing here I want to point out is for this overall stack, actually, we also package it as the skills. So we also have the FlagOS skills. It helps you to deploy, do the code generation, to do the easy migration, to talk to the agent, okay. Then first, when we consider to enable the AI model or algorithm on different architecture, the first thing we need to do is to handle the compiler, okay. Actually, 3 years ago, when we start this work, we also used the Rust language to implement a totally new compiler for this purpose. But it's quite challenging that because no any vendor at that time willing to support a totally new compiler. So that's why at that time, we a little bit give up that Rust-based compiler because the ecosystem hasn't come up yet. So we turned to the Triton. At that time, the Triton compiler already started be supported by PyTorch and also the different vendors in the world. Okay, but after some years, we found that the mainstream, the Triton compiler maintained by OpenAI is not good enough. It cannot support a lot of different backends. Still, they mainly focus on the AMD or NVIDIA, but cannot support more broader the backend. Second, it cannot represent a lot of hardware architecture features, so that we cannot get the better performance. And Triton language itself is very good for the productivity, but not so good for efficiency, hardware efficiency. So that's why we, 2 years ago, we started this new project called FlagChi. Actually, you can regard it as an augmented Triton compiler. It already can support a lot of different backend in single stack. Don't need the chipset vendor, they fork the compiler code and develop their own. Actually, we already support 12 different backend in the single code base. But last year, we found that the language is another issue because usually for language, when we design the language, usually we purpose it into in this curve is the productivity versus performance. Usually we will design the language for a single point. But for Triton, we want to use it to also support the hardware in good performance. So that's why we extend the language for Triton to the curve. That means that it can better balance or give the more choice to our developer to better choose if they want to have the better productivity or better performance. So that is called the TLE, Triton Language Extension. Actually, it divided into the 3 layers, the Triton Language Lite, the structured or raw, different layer for different expert level of developer. So here we in the past several months, we just released this new language, which already show up the huge performance enhancement compared with the native Triton language, but also we compare it with the C language. For example, the CUDA-C or Zen-C on Huawei, we also get a very good performance, okay? So based on that, actually, the second thing is when we do this replacement, the underlying replacement, kernel replacement for DeepSeek. DeepSeek today, they have 67 different CUDA or Thailand kernels. We need to replace them to this Triton base so that it can run on different architecture. So it depends on because we have this largest operator library in the world written in Triton. FlagGems, it has already more than 400 different operator frequently used by AI models, okay? It also be part of the PyTorch ecosystem as well. So we use this to replace the kernels and also optimize it for a lot of the performance things, including we add the C++ wrapper, which really reduce the Triton launch overhead, okay? And as I mentioned, in the compiler, we found that the language is not good enough, so we extend it. But as in the Rust previous introduction presentation, we all will face this challenge. If we introduce a new language, usually it will take years for the developer to get familiar with a new language, okay? But today, it is AI to write the code. So it's not human to write the code. So today, it will be much easier for us to introduce a new language because we only need the agent to understand how to code the algorithm in this new language. It's not the human, okay? So, sorry. So this is another, the second thing we think very important when we do the migration for the DeepSeek. The first is this is the toolchain to automatically generate the operator kernels. We have a huge number of operator kernels to support AI in the world today. Thousands of kernels, okay? We cannot implement it one by our experts. So currently, we already have 80% of the kernels already implemented by this tool. We call it the kernel gen. It supports a different architecture. It supports a media backend, a Zen backend, or also other AI chipset backend. And it will help you to generate the code, generate the test case, and also do the precision benchmark to ensure the correctness, and also do the speed up testing to ensure the optimization. If the optimization is not satisfied, it will automatically help you to do it again. So we wrap it up as the platform and also the MCP and skill to allow you to use it in different way. And it can get a quite good performance compared with the cloud code. We can use the much less the token with this agent and get an even better performance. So in the back in the DeepSeek, yes, we have at least the 3 new kernels implemented by this tool. That's how, and run it on different architecture. So that's how we can very quickly, just 1 or 2 days, finish all the migration because we also have this tool. And the other thing I highlight is it supports the Triton TLE. As I mentioned, this is the new language extension, but we don't rely on the developer to get familiar with that. We actually rely on the agent to help us to generate the new code, which is very, very high performance for the operator, okay. And as I mentioned, when we do the migration for the DeepSeek, we need to change the code, we need to change the backend dependency, and we also need to do a lot of testing to ensure the precision, ensure the correctness, and also the benchmark result. So we actually built up the pipeline called the Flag Release. It is to download the open source code, open source model, migrate it onto the target hardware, and do the test, and release it again. So today on Hugging Face, we already support a lot of different open source models, including the Minimax, GLM, Quen, Mini CPM, and Llama, and others, okay? And the user just download it, and with the name of the backend, and run it in 3 steps, because we open source migrated the WAV file, the code, and also the image, the Docker image, okay? And so after, with all those kinds of kernel libraries, FlagGems, compiler support, and also a lot of optimization and testing and tool chains, we actually just use a very short time, finish the migration of the DeepSeek version 4, including the prop version and flash version. And we finally supported on 10 different AI chipsets, okay? And all released on the Hugging Face. People can feel free to download that. And also we have the one-stop the code on the GitHub. You can get all the required toolchain to do the different precision conversion, okay? So, and besides the DeepSeek, we also already support the different model in the first 3 months in this year, okay. And the other thing is actually we built up the whole stack to allow the different chipsets to connect to our compiler. We have the libraries, but one more important thing is how can we put these things into current those very important engines. For example, VLLM, SGLang, these are very important inference engine. And currently, they don't provide very strong support for different backend. So we developed a unified plugin system. It is to help to put our all FlagOS capability as the plugin to plug into the VLM, SGLang, and other Metron LM for training, and TE for training, and also VRL for the reinforcement learning. So our target is to help, once we can solve the multi-backend issue, then we want to help the different community or open source project easily to benefit from this FlagOS stack. So that's why we developed the unified plugin. And we have already released some of them. We are ongoing to work on the next one in this month. It should be SGLang plugin, okay? So we also very looking forward to the close collaboration with this important open source community. Okay, this is the last thing is OpenCompute actually is very important. It's not only to enable the model on different hardware, but more important is we want to use this way to let those underutilized hardware be used by more people. So we can imagine that today, no matter in China, US, or other places in the world, there's still a lot of underutilized AI hardware. Once the AI hardware has been upgraded to the next version, then the old version, a lot of them might be underutilized. So can we group them and provide the remote access to those developing country or regions so that there can be more students in university, they can benefit from it and also do some kinds of research or education on it. So that is very initial idea. And around 1 year ago, start from here, Gosim 1 year ago, we start this conversation and collaboration. And I'm very glad that after 1 year, we have collaborated with a different party in the world and make the first case happen. It is for the collaboration with Africa Union, the Research Council under the Africa Union. And we already supported the teachers from universities from more than 10 different countries in Africa. They take take the learning course in our lab in the last month. And also we use this OpenCompute, build up the online lab. And that online lab actually in the backend, it is more than 100 AI devices from different vendors. So we use this way to teach those teachers, to give them this resource. They can start to consider how to let their students to do the homework on that. And when they return their country, they will start to launch the new courses for the AI education and allow their students to do this remote education through this online lab, okay? So this is the very first step, and we also look forward to the broader collaboration in different places. Okay, last is let's build the open compute together. This is the invitation, and also we very looking forward to the collaboration in open source community, and we want more from you to participate together, and we build a beautiful future. Thank you.